Okay, sections 4.2 and 4.3 I'm going to combine together kind of as one. We're going to talk about zeros of polynomial functions. The first thing that we need to talk about is polynomial division. This will be a review, hopefully. So the first thing is dividing a polynomial by a monomial. A monomial is a polynomial that only has one term. So for example, suppose we have 5x to the fourth minus 30x squared plus 3x divided by 15x squared. Well, I can split up the 15x squared into the three terms there and divide each of the three terms. 5 over 15 is 1/3. X to the fourth over x squared is x squared, 1/3 x squared. Minus the x squareds cancel there, so 30 over 15 is minus 2 plus 1/5 x, 1 over 5x. Okay. Dividing a polynomial by a monomial, I don't think is so bad. Okay, all you do is split up the polynomial into the number of terms that there are, and then divide each of the terms by the monomial. Division by polynomials is a bit different, though. Suppose, for example, we want to divide 175 divided by 3. Okay, so 3 goes into 175. Well, 3 goes into 17 5 times. That'll get me to 15, and I subtract 15 from 17. That gives me 2 left over. Bring down the 5. 3 into 25 is 8. That gets me to 24. I subtract 24 from 25. That gives me 1 left over. 1 is the remainder, and the complete leftover is 1/3. So 175 divided by 3 as a mixed number is 58 1/3, and that's exactly how you'd find the mixed number form. Okay, so for example, suppose that we had 2x squared plus 5x minus 3 divided by x plus 3. Well, x plus 3 is going to go outside the division bar. 2x squared plus 5x minus 3 is going to go underneath it. And I'm going to begin by thinking of an expression such that when I multiply by x, I get 2x squared. Well, 2x will do it. 2x times x is 2x squared plus 6x. Okay, and I want to subtract the whole thing. 2x squared minus 2x squared is 0. 5x minus 6x gives me negative x. And I can bring it on the minus 3. And I can divide it again. So if I tack on a minus 1 there, negative 1 times x plus 3 gives me negative x minus 3. I'm going to subtract that again. I always subtract these resulting expressions. Negative x plus x is 0. Negative 3 plus 3 is 0. So I get 0 left over, a remainder of 0. And I can easily check that if I take what I think is the answer times the divisor. I should get the dividend, okay, which is the expression underneath the division bar there. Okay, so 2x minus 1 times x plus 3 gives me 2x squared plus 6x plus minus x is plus 5x. Negative 1 times 3 is minus 3. And yeah, that's exactly what I get as the dividend. Okay, so that was good there. 2x minus 1 is the answer. Suppose we have 12x cubed minus 14x squared plus 7x minus 7 divided by 3x minus 2. Okay, well, the 3x minus 2 is going to go outside the division bar, and the 12x cubed minus 14x squared plus 7x minus 7 go underneath it. You always start with letting what's in the numerator go underneath the division bar, and the denominator go outside the division bar. Okay, and we're all set up to begin dividing now. So I'm thinking of a number such that when I multiply by 3x minus 2, I get 12x cubed, leading off. 4x squared should do it. 4x squared times 3x minus 2 gives me 12x cubed minus 8x squared. Okay, and I'm subtracting that. That way the 12x cubes go away. Negative 14x squared plus 8x squared gives me negative 6x squared. And I can bring down these remaining terms, and I can divide again. If I divide by negative 2x, negative 2x times 3x minus 2 gives me negative 6x squared plus 2x, plus 4x. And I'm subtracting that. Negative 6x plus 6x squared, gives me 0. And 7x minus 4x gives me 3x. Bring down the minus 7. And 3x minus 2 goes into 3x minus 7 one time. So I went 1 there. And 3x minus 2 gets subtracted. 3x minus 3x is 0. Negative 7 plus 2 gives me negative 5 as the remainder. Okay, the remainder always gets added to your answer. Okay, so I got plus the remainder over the divisor. Okay, the quotient plus the remainder over the divisor is the form that I want. In other words, when you take 12x cubed minus 14x squared plus 7x minus 7 divided by 3x minus 2, you get 4x squared minus 2x plus 1 plus negative 5 divided by 3x minus 2. And I've got just a note here. Whenever you take the dividend over the divisor, which is what these things are, okay, you always get what's called a quotient plus the remainder over the divisor. Write the answers in this form, just for all practical purposes. Okay. Another example. Suppose that we have 2x cubed plus 7x squared minus 5 divided by x plus 3. Well, x plus 3 is going to go outside the division bar. 2x cubed plus 7x squared minus 5. Leave a gap between those last two terms there, just so when we divide, we make sure our columns are in line. And I'm thinking of a expression such that when I multiply by x plus 3, the leading term is 2x cubed. 2x squared should do it. 2x squared times x minus x plus 3 gives me 2x cubed plus 6x squared. Okay, and I'm subtracting that, so 2x cubed minus 2x cubed is 0. 7x squared minus 6x squared is x squared. Negative 5, you can bring down the negative 5 there, so you get x squared minus 5. Okay, x is the next term. X times x plus 3 gives me x squared plus 3x. X squared minus x squared is 0. 0 minus 3x is negative 3x. And then negative 5 plus 0 is negative 5. Okay, and I can divide again, looks like, by using negative 3. Negative 3 times x plus 3 gives me negative 3x minus 9, and I'm subtracting that. So negative 3x plus 3x is 0. Negative 5 plus 9 is 4. Okay, 4 is the remainder. And x plus 3 is the divisor. Okay, so I've got the quotient plus the remainder over the divisor, or what I see in this form here. Another thing that we're going to have to know and be good with is a synthetic division. Synthetic division is a shortcut for dividing a polynomial by a binomial. A binomial is a polynomial that only has two terms on it. Okay, so like x and 3 is two terms. Okay, suppose that we have the same problem here as 2x squared plus 7x, 2x cubed plus 7x squared minus 5 divided by x plus 3 divided by x, divided by x plus 3. Okay, and I'll show you how to get the same answer, same result. but by using synthetic division. Okay, so the first thing I want to do is I want to put what's called the zero of the denominator. -3 would be the zero of the denominator because that creates 0 in the denominator. Put that on the side, and -2 or 2 comes down, and I guess the numbers that I want on the top row would be 2, 7, 0. Because I don't have any x's, and then -5 at the end. Be sure that you don't forget about this 0. Okay, we must have this 0 there, otherwise we get the wrong answer. So step 1 is to bring the 2 down. 2 times -3 is -6. 7 minus 6 is 1. 1 times -3 is -3. 0 minus 3 is -3. -3 times -3 is 9, and -5 plus 9 is 4. Okay, so, and that's exactly what I get when I simplify here. So 2x cubed plus 7x squared minus 5 divided by x plus 3 gives me 2x squared plus x minus 3 plus 4 is the remainder. Usually we have a line by 4, or by the remainder. You can have that or not; it doesn't matter. We make sure that you have a plus sign though. Okay, I sometimes see students don't write a plus sign there, and then it looks like multiplication, and then it counts the answer wrong. Okay, so plus 4 divided by x plus 3. Okay. The remainder theorem, and by the way, we're going to use synthetic division all over the place coming up next. Okay, so they want you to be good with synthetic division. You're going to use it a lot, like I said, coming up in these next 2 sections. Actually 4 sections, if you count the division part. The remainder theorem says that if a polynomial f of x is divided by x minus c, the remainder is f of c. Okay, so for example, suppose that we take 2x cubed plus 7x squared minus 5 as f of x. And -3 is the 0 of the denominator. So I should get the remainder here, which I know is 4. Okay, when I plug 3 in, and -3 in. F of -3 gives me -3 cubed is -27 times 2 is -54. -3 squared is 9 times 7 is 63 minus 5. -54 plus 63 minus 5 gives me 4. So because I'm not getting 0 as the output, I would conclude that x minus 3 is not a factor of f. Now, with some playing around with the numbers here, if I take this guy here and divide by x plus 1, then f of -1 gives me 0. Okay, and I can check that. So x plus 1 is a factor of f. X plus 3 is not a factor of f. Okay, so anytime you get 0 coming out of the calculation, the number is called a 0 of f, and therefore the remainder is f of c. Okay, we'll stop right there.